Chemical Equations Foundation Course 6.1. A chemical equation is a quick way to show which atoms react together, but also how many. It's like a recipe. In the first example here, the equation tells us that one iron atom and one sulfur atom react to give one iron sulfide. The plus sign means and the arrow means reacts to give. The second example shows two molecules of hydrogen gas and one molecule of oxygen gas react to give two molecules of water. Here we can see the rather violent reaction of hydrogen and oxygen. Writing chemical equations. There are 4 rules for writing chemical equations. These are best described with an example. Example 1. Magnesium metal reacts with oxygen gas to give magnesium oxide. Rule 1. Write down the word equation. Magnesium metal plus oxygen gas reacts to give magnesium oxide. Rule 2. Write down the symbol equation. It is important to get the formulae correct here. Mg plus O2, oxygen gas is always O2, reacts to give MgO. Now to work out the formula of magnesium oxide, you need to use the periodic table. Magnesium is in group 2, so forms the Mg2+ ion. Oxygen is in group 6, so forms the O2- ion. Remember, a compound must be neutral, so one Mg2+ and one O2- ion is neutral. This gives the formula of magnesium oxide, MgO. Balance the equation. On the left-hand side, we have one Mg atom. On the right-hand side, we have one Mg atom. On the left-hand side, we have 2 oxygen atoms. On the right-hand side, we have 1 oxygen atom. Now you cannot simply add a second oxygen atom to the magnesium oxide, as this does not exist. The only way more oxygen can be added to the right-hand side is by adding a complete new MgO. This now gives us the 2 oxygen atoms, but adds another magnesium atom to the right-hand side. We now need to add another Mg to the left-hand side. Our equation is now balanced, but needs to be simplified. Place a 2 in front of the Mg, as there are 2 Mg atoms, and a 2 in front of the MgO, as there are 2 MgOs. Rule 4. Add the state symbols, solid, liquid, gas or aqueous. This is their state at room temperature, 20 degrees centigrade. Aqueous means in a water solution. Mg is a solid at room temperature. All metals are solid at room temperature, except mercury. Oxygen gas is of course a gas. Magnesium oxide is a solid. MgO is an ionic substance. Easy to tell as it contains a metal and a non-metal. All ionic substances are solids at room temperature. This is now the fully balanced chemical equation and is found in this form in all chemistry textbooks in every country in the world. Example 2. Sodium metal burns in oxygen gas to give sodium oxide. Rule 1. Write down the word equation. Sodium metal plus oxygen gas reacts to give sodium oxide. Rule 2. Write down the symbol equation. It is important here to get the formulae correct. Na plus O2, oxygen gas is always O2, reacts to give NaO. To work out the formula of sodium oxide, you need to use the periodic table. Na is in group 1, so forms the Na1 plus ion. Oxygen is in group 6, so forms the O2 minus ion. Remember, a compound must be neutral, so you need 2 Na1 plus ions for 1 oxygen 2 minus ion. This gives the formula Na2O. Row 3 balance the equation. On the left-hand side, we have 1 sodium atom. On the right-hand side, we have 2 sodium atoms. So we need to add another sodium atom. On the left-hand side, we have 2 oxygen atoms. On the right-hand side, we only have 1. Now we cannot simply just add another oxygen atom to the Na2O, as this does not exist. The only way we can add more oxygen to the right-hand side is if we add a complete new Na2O. This now gives us the 2 oxygen atoms we need, but has added a further 2 sodium atoms. So let's add these to the left-hand side. Our equation is now balanced, but it needs simplified. Since we have 4 Na atoms on the left-hand side, we put a 4 in front of Na. Since we have 2 Na2O substances, we need to put a 2 in front of the Na2O. We can now just remove the remainder. Like so. And we now have our balanced equation. Rule 4. Add the state symbols: solid, liquid, gas, or aqueous. Na is a solid at room temperature. All metals are solid at room temperature except mercury. Oxygen gas is of course a gas. Na2O is a solid. Na2O is an ionic substance. Easy to tell as it contains a metal and a non-metal. All ionic substances are solids at room temperature. The equation is now a fully balanced chemical equation as found in all chemistry textbooks. Example 3. Aluminium metal burns in chlorine gas to give aluminium chloride. Rule 1. Write down the word equation. Aluminium metal plus chlorine gas reacts to give aluminium chloride. Rule 2. Write down the simple equation. It is important to get the formulae correct here. Al plus Cl2, chlorine gas is always Cl2, reacts to give AlCl. To work out the formula of aluminium chloride, you need the periodic table. Al is in group 3, so forms the Al3 plus stable ion. Chlorine is in group 7, so forms the chlorine 1 minus ion. Remember, a compound must always be neutral, so 1 Al3 plus ion must join with 3 Cl1 minus ions. This gives you a formula of aluminium chloride as AlCl3. Rule 3. Balance the equation. On the left-hand side, we have 1 aluminium atom. On the right-hand side, we have 1 aluminium atom. On the left-hand side, we have 2 chlorine atoms. On the right-hand side, we have 3 chlorine atoms. Now we have an odd number of 3 chlorine atoms on the right-hand side, so we must double this to make 6 to make it an even number. Otherwise, we can never balance the equation, as the left-hand side can only have an even number of chlorine atoms. So multiply it by 2. On the right hand side, we now have 2 aluminium atoms and 6 chlorine atoms. We need to add this to the left hand side. So we add a 2 in front of the aluminium, and a 3 times 2 in front of a chlorine makes 6. The equation is now balanced. Rule 4. Add the state symbols, e.g. solid, liquid, gas, or aqueous. Aluminium is a metal, so is a solid. All metals are solid at room temperature except mercury. Chlorine gas is of course a gas. Aluminium chloride is an ionic substance. All ionic substances are solids at room temperature, so aluminium chloride is also a solid. This is now a fully balanced chemical equation. Example 4. Magnesium metal reacts with nitrogen gas, N2, to give magnesium nitride. You should now pause the video here and try this example on a piece of paper by yourself. You will need a copy of the periodic table. I will show the solution on the next slide. Please pause now. I hope you were able to come to the same balanced equation as here. The formula of magnesium nitride is obtained from the combination of the Mg2 plus ion and the N3 minus ion. A neutral compound is obtained with 3 Mg3 plus ions and 2 N3 minus ions. If you didn't come to this equation and don't understand why, then I suggest you review the video again or ask me or a classmate for assistance. Another type of chemical equation you should be able to balance are those containing organic molecules. The first example here is methane gas, CH4. This is used for heating and running some cars and buses. Example 5. Methane gas, CH4, burns in oxygen gas to give carbon dioxide and water. The word equation and the symbol equation are quite straightforward here. You should hopefully know that carbon dioxide is CO2. 3. Balancing the equation. We have 1 carbon on the left hand side and 1 carbon on the right hand side. We have 4 hydrogens on the left hand side, but only 2 on the right hand side. We need to add another water molecule. This now gives us the 4 hydrogen atoms, but also adds some more oxygen atoms. On the right hand side we now have 2 oxygen in CO2 plus 2 in each of the water molecules. That makes 4. So we need to add 2 to the oxygen on the left hand side. The equation is now balanced and is shown here. 4. Add the state symbols. Methane is a gas, oxygen is a gas, carbon dioxide is a gas, and water is of course a liquid at room temperature. Balanced. Example 6. Butane gas, C4H10, burns in oxygen gas to give carbon dioxide and water. Again, word equation is quite straightforward, as is the symbol equation. 3. Balance the equation. On the left hand side we have 4 carbons, so we need to add a 4 to the right hand side. That's 4 carbon dioxides. On the left hand side we have 10 hydrogen atoms, so we need to add a 5 in front of the water molecule to give us the 10 hydrogen atoms. Now if we add up all the oxygen atoms, we get 4 times 2 is 8, here we have 8, and here we have 5. That makes 13 oxygen atoms. The only way we can get 13 with O2 is 6.5. And this gives us the balanced equation. This balanced equation is of course normally accepted. 6.5, 6 quarters, 3 quarters are also used. But if you're unhappy with using halves, quarters or thirds, you can of course double the equation here. If you double everything, then this becomes 2. This now becomes 13, this becomes 8, and this becomes 10. And we now have our balanced equation here at the bottom. The last thing we need to do is to put in the state symbols. Butane is a gas, oxygen is a gas, carbon dioxide is a gas, and water is, of course, a liquid at room temperature. This gives us our fully balanced chemical equation. Time for some practice questions. Give the balanced equations with state symbols for the following. You should now pause the video here and try these examples on a piece of paper by yourself. I will show you the solutions on the next slide. Please pause now. I hope you were able to come to the same balanced equations as here. If you didn't get these results and don't understand why, then I suggest you review the video again or ask me or a classmate for assistance. You should now complete the multiple choice test Chemical Equations Foundation Course 6.1. You'll need a copy of the periodic table.